All right, so I'm going to start off with a simple JPA application that's going to take in a person's name and age and persist that to a database. So nothing special has been done to this application to make it work with the stack or to make it run in Kubernetes. This is just a simple app that I have locally on my laptop. As you can see, there's just a assets directory with some JPEG files. There's just a source with some Java and tests, git ignore, and a POM XML. So all very basic stuff. So over my terminal, I'm currently logged into my OpenShift console, and I have ODO installed for the command line tools. So to initialize this application with the stack, I simply need to say ODO create. I'm going to give it the name of the stack that I want. That's Java Open Liberty. And I'm going to give this component a name. So I'm just going to say my Open Liberty component. So the stack is now initialized, or the application is now initialized with the stack, I should say. And you'll see that there's now this dev file that's been downloaded into my application. Now this is the dev file associated with the Open Liberty stack. And it was pulled from the default dev file registry, which ODO is pointing to. But you could also imagine having a custom tailored dev file. Perhaps you extend the out-of-the-box one that we have for your particular business needs or application needs. And you can have that in a different registry that you can now easily point ODO to pull that if you'd like. But for now, we're going to use the dev file associated with the stack. So let's take a look at that. So this dev file is the brains behind the Open Liberty stack. And a few things that I want to note here. Under components, we will see that we have an image defined. And this is that development image that I mentioned in the presentation. This includes Open Liberty. It includes OpenJ9. It has Maven in this case because we're using a Maven application, and it has a bunch of cached libraries and dependencies that will make your app run a bit quicker. So all of this is contained within this image here, and the dev file is basically specifying that this is the image to use when building and running the application. Also, we have these commands that we have listed here, and depending on what you want to do with your application, there's different commands. For example, to run your app, to debug it, to test. These are all the commands that are run under the covers by the stack, depending on what you want to do. And you'll see here, if you want to run your application, we're running this Maven command here, and we're actually running Liberty Dev Mode under the covers. So now if I want to build and run my application, I simply say ODO push. And if we go over into my OpenShift console here, I can now see that I have this new pod that's initializing automatically my Open Liberty component. So back at my terminal, you can see that we're running a few initialize scripts that we have for the stack. We'll eventually, in a few seconds, run the Maven command to build and run in dev mode. There we go. And all of this takes roughly about a minute, probably a little less to run, depending on your network speed, depending on the speed of your remote cluster. Now, if I want to see where we are with the build and see if our server has started, I can do ODO log. And this is going to pull the logs from my pod and put them out to my terminal here. Now this ODO log is very static. It just prints what we have available at that moment for as far as logs are concerned. But I can also do an ODO log -f, which is going to stream the logs out to my console. So we can see that our server has been started. And because we're running in dev mode, we're going to have whatever tests that we have associated with this app running as well. And as expected, of course, our tests are failing because we still don't have a database yet connected to this application. So let's go ahead and do that. So if I want to start up a database, or really any resource, I can do an ODO catalog list services. And we'll see what services are available for creation. And you'll notice when I was over in my console before that I had this PostgreSQL Operator installed. So I had done this beforehand. This will allow me to create this service. It was very simple to install, just a few clicks from the operators tab over here. And I have this now available in my namespace. So I'm going to go ahead and use this Postgres operator. I'm going to do ODO service create. I'm going to specify the database. And if I were to run this command now, it would automatically try to create that database. But I don't want to do that yet. I want to make a few modifications to the YAML for this database. So I'm going to say --dry run, which is going to spit some YAML out to my console. And I'm going to save that instead to db YAML file. So let's go ahead and open that and see what that looks like. So very simple YAML file just to create that database out in my cluster. I'm going to change a few things here. I'm going to just call this sample DB, sample password. Now ideally you probably want this to be encrypted. For demo purposes, I'm just going to have it in plain text, sample user. And one other thing that I would want to do with this YAML file is add a few special annotations for the service binding operator. So I mentioned earlier in the presentation that ODO link, which we're going to run after this to link to our application, is going to use the service binding operator. And the service binding operator needs a few annotations within your resource so it knows where it is, it knows what to monitor, and what information to pull from that. So I have this saved over here. Let me put this into the metadata here. And all this is telling the service binding operator is that I want the database name, the database password, and the database user to be injected into my application. So these environment variables here are now going to be injected into my app by the service binding operator when I later do an ODO link. So let me save this file. Now back over in our terminal, now I want to actually create this service. Rather than just a dry run, I'm going to do service create, and since we have that file, I'm going to do -- from file db YAML. And now if we go back over to our dev file, we'll see that we have this new resource that's been added under this Kubernetes tab here. And this is all the YAML that we just saw before. If I want to sync this now with my pod, or with my cluster, I should say, I simply just do another ODO push. Now back over in our OpenShift console, we can now see that we have this sample database pod that is now being created. There we go. So now that I have my service created, I can now do an ODO service list to see if it's available. You can see here that we have sample DB. So to link this now to my application, I simply just need to say ODO link database /sample DB. Let's go back over to our dev file. We see that we have another resource that's been added, a service binding resource. So this is associated, as you can imagine, with the service binding operator. And this is simply telling it that there's this database that we have, and we want the correct information that's in those annotations to be injected into my application. So let's go ahead and do another ODO push. And because we're updating environment variables, ODO does require that the pod is restarted. And we can see that over here that we're terminating. We're going to be restarting this. Typically, when you sync changes to your pod that's running as part of the stack, the pod does not need to be restarted. Everything is picked up automatically. For example, application changes or anything like that. But like I said, because these are environment variables, we're restarting the pod, which just adds a couple more seconds to the process. Let's wait for that to complete. All right, so let's do another ODO log, see where we are. ODO log -f to stream. Now occasionally ODO log -f, because we're streaming updates to the output. If there's something that's downloading, for example, we're not going to see update in our terminal right away. So give that a few seconds. There we go. See our server is starting. We're going to be running our tests, all of which should pass now. Looks like there's a few errors. We're running them again just to make sure. There we go. So our tests are passing, our database is connected, we're all ready to go. So now if we want to access this application from our browser, the stack automatically creates a URL for you as part of your cluster. It's a route in OpenShift. So to access that, we can say ODO URL list. Let's go ahead and grab this. Over in our browser, and we can see that we have our application. We have a couple things that are primed as part of this application. Let's go create a new person. Let's say Bob, age 50. Let's say we create another. Let's just say John, age 40. Can go ahead and delete Mary. And all of this is being persisted in our database that we have set up with ODO. So now I'm ready to start developing my application. Now every time I make a change to my app, I can simply go back and say ODO push, or for convenience, I can simply say ODO watch. Now ODO now has a watcher that's set up on our application, so anytime anything changes and a file is saved, it's automatically synced with our pod. So let's go ahead and see what that looks like. So back in our app, let's change some Java code here. So we have this person resource here that has all of our endpoints. Down here I have one that's commented out. Let's go ahead and uncomment that. So we've now added an endpoint to our application is at /API, and this resource here is at /demo. So /API/demo, we'll be able to get this string back to the browser. So once I save this file, I can now see over in my terminal that our stack is automatically picking up those changes. We're automatically syncing those with our console. Nothing has to be restarted. Dev mode is picking it up automatically. And if all goes well, we can go here to our application, API/demo, and we can see that our new endpoint is available.